I am Anil Kumar. Welcome to my series on advanced functions. In this video, we'll discuss thinking and application question based on inequalities. Now, this particular question involves three different kinds of functions, and therefore, we are going to have a very integrated approach with multiple functions to solve. It is a very important question from examination point of view. The question here is, write a linear function g of x such that it is greater than f of x equals to x squared minus 1 when absolute value of x minus 1 is greater than 3. 5 choices are given to you. You can pause the video, answer this question, and then look into my suggestions. Now, let's first talk about the approach. You can actually pause and work out the solution and then look into my solutions. So here the approach is that we are saying that we write a linear function. This is what we need to find, which could be one of these five, a, b, c, d, e, such that it is greater than f of x equals to x squared minus 1 when a limit is given for an absolute function. So strictly speaking, the question is kind of like this. We need to find g of x, which is given to us as linear, so that it is greater than f of x equals to x squared minus 1. And the condition when we also have absolute value of x minus 1 greater than 3. So we have to meet both the conditions. Perfect. Now let's look into these functions individually before jumping into the solution. So when I say absolute value of x minus 1 greater than 3, what do I mean? It really means that, let's say we sketch this function absolute value. Let's say this is 1 for us. So here is this function absolute value of x minus 1. Now, when we say it is greater than 3, then it means that somewhere, so if it is 0, it is going to be 1. So it's not a very accurate drawing, but think like this, that somewhere here, we're looking for this interval. Let's call this point A and B for time being. And of course, the y value at this place should be 3. So we're looking for a region which is beyond A and B. So in this interval, what we want here is that the linear function is greater than the absolute function. Let me sketch this also on the side, different graph. It could have been done on the same graph also. So let us say we have this particular function, and I'm going to use a different color here. So let's say x squared minus 1, that means the parabola is kind of like this. And this point being minus 1. So that is the function f of x. And in this interval, which is let us say a, we'll find these values, and b, in this interval, we have a linear function. So basically in this interval, we have to find corresponding points on the graph of the parabola, right? And if I join these points with a line, this line is g of x. And when we say that g of x is greater than f of x, that means we are looking for the region beyond this, right? So this is what we're looking for. So, sorry. What we're looking for is this interval, right? Beyond this. So that is the interval which we are looking for. And now it makes sense. Do you see that? So that is how we are going to approach solution of this particular question. So I hope the concept is absolutely clear. With this in mind, now let us take the solution. So first step here will definitely be to find the interval when absolute value of x minus 1 is greater than 3. So when we say that, it really means that x minus 1 is greater than 3 and x minus 1 is less than minus 3. That is what we mean, right? So we'll solve this independently and get our solution for those points A and B. So solving, we get x is less than minus 3 plus 1 or x is less than minus 2. Here we get x is greater than 3 plus 1 or x is greater than 4. So clearly we have our interval now, and the interval here is, we have space, so let me just use the space here, is basically, so this point, we'll assume this to be x equals to 1, and so let's say this is 4 for us. So let's say this is 4 for us, and this is, let's say, minus 2. So that is the interval where the function g of x should be greater than f of x. Is that clear to you? So now we have an interval, and the interval for us is defined as x which is less than minus 2, or means union x is greater than 4, and in this interval we want the linear function g of x to be greater than the parabolic function f of x. Perfect. So we'll find the point of intersection. So on the function f of x, which is given to us as x squared minus 1, let us find the y values when x is minus 2. So we get minus 2 whole square minus 1. So we get a value for f of minus 2 as equal to 4 minus 1, which is 3. And similarly, let's find the value when x is 4. So in that case, we get 4 square minus 1, and we know that f of 4 for us is 16 minus 1, which is 15. So we get 2 points. So that gives us 2 different points, and these points are, let me write down the points in a different ink. We'll call them as point A and B. So point A for us is right there, which is for x equals to minus 2, the y value is 3. And the point B is the point where when x equals to 4, y equals to 15. Now the line, which is g of x, is passing through these 2 points. Perfect. So now let's find the equation of this particular line. So we'll find the slope first. M a to b is what? Well, y2 minus y1 gives us 15 minus 3 divided by 4 minus 1, which becomes 2, which is 12 over 6, or slope is 2. And that gives you the equation. We can write the equation in terms of y minus y1 times equals to m times x minus x1. So y minus, we can use any one of these points. Let's use the very first one. So y minus 3 equals to slope, which is 2. X minus minus 2 becomes plus 2. And we can bring all the terms together. So we get y equals to 2x. 2 times 2 is 4. And we'll add 3 to this. And so we get our equation y equals to 2x plus 7. So that is the function g of x, right? So g of x is equal to 2x plus 7. Does make sense to you? So that is how we actually get our solution, which is 2x plus 7 is C. And so we'll answer by selecting the option C. Is that clear to you? Perfect. So let's get back to where we started. So we got the interval, which is having 2 critical points, which are for us minus 2 and 4. We calculated these points, and these were at -2, and at 4 we had 15, and at -2 the point was 3. Okay, so point was -2 and 3. So using these 2 points, we got the function g of x, and we found that this equation is 2x plus 3. Does make sense to you, right? So that is how we are actually going to solve this question. So it's a very interesting question. I had posted a very similar question in one of the test papers, and some students had queries. And I now understand that this particular explanation is going to help understand the whole concept. I hope that is beneficial for all of you. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best.